Hello guys, I hope you are doing well. So today we are gonna talk about logarithms. We're not gonna go really deep into the topic, but it's easy anyway. So let's get started. At first, let's start with the beginning, why logarithms were made, etc. So first, logarithms were used in general in astronomy. The point of constructing them is to make calculations of big numbers easier. So if we take for example distances between stars, etc., they are really big numbers. So logarithms allow us to make these big numbers small, or easier to work with. The second reason is to calculate sums instead of calculating products, and we're gonna see this how this works deeper here. So definitions, we define the natural logarithm or the Neperian logarithm as ln of x. So instead of writing f of x of a general function f, we write ln of x, where x is strictly positive numbers, so it must be strictly superior than 0. So we have some rules here. The first one is the logarithm of 1 is equal to 0. The limit when x gets closer to 0 is of the logarithm of x is minus infinity, and the limit when x gets bigger of ln of x equals plus infinity. So for every x in 0 plus infinity and y in 0 plus infinity, we have the following rules. The logarithm of x times y equals the logarithm of x plus the logarithm of y, and the logarithm of x divided by y equals the logarithm of x minus the logarithm of y. So as you can see here, and as we said before, we took this product of x times y and we made it into a sum, which is the logarithm of x plus the logarithm of y, which makes things easier. Calculating sums is much more easier than calculating products. And here, when we have a division, x divided by y, we get the logarithm of x minus the logarithm of y. For every a n 0 plus infinity and b n minus infinity plus infinity, we have the logarithm of a to the power b is equal to b logarithm of a. So we take this b out and we made it as a multiplication factor here. So back to the beginning to verify if the things we wanted are really here. So if we are to calculate big numbers in astronomy, for example, let's take the speed of light, which is about 3 to the power 8 meter per second. When we calculate its logarithm, we get the logarithm of 3.10 to the power 8 is equal to the logarithm of 3 plus the logarithm of 10 to the power 8. So we took this product and we made it into a sum. And then we're gonna use the third rule, and this is gonna give us the logarithm of 3 plus 8, the logarithm of 10, because we took this out from here. So now we only have to deal with sums instead of products, and on the other hand with small numbers instead of big numbers. So here is the graph of the logarithm of x. If we look here, so it starts from minus infinity. It's not defined on the negative numbers, and here it starts from minus infinity and it keeps getting bigger and bigger, and x equals 1 it is equal to 0, and it keeps going to infinity here. One last point is the derivative and integral. So since we are talking about logarithms, I guess you are familiar with the notions of derivatives and integrals. So the logarithm is a continuous derivable function on the interval 0 plus infinity, and we have the derivative of ln of x is 1 over x, and the integral of ln of x dx is equal x ln of x plus c, where c is a real number. So thank you so much guys for your attention. I hope everything is clear. As always, if there is a problem or you have any questions, don't hesitate to ask in the comment section. Thank you so much and see you later.